The interesting architecture company has designed a building with a constant cross-section shown in the figure below. With reference to the figure, the height h of x of the building at a point x along its width is given by this function h. We can see the domain of that function is from 0 to w, and everything is measured here in meters. We want to determine the width of the building correct to the nearest centimetre. So this is just going to be a CAS job. You could solve for h of x equals 0. Another way of doing it might be to go to graph and table. As you can see, I've now typed that function in, and then I'm just going to graph, and obviously it's not quite fitting at the moment. So if I've got negative 5.5, let's maybe put this out to 20 or something. And everything else there might be okay. And here's our graph, and we can see that the cross section goes from the origin to where it crosses the axis here. So what we really want is to find the roots. And obviously the first one is at 0, and the next one is at 8.64 if we round to 2 decimal places. So 8.64 meters, and that's correct. 2 decimal places here is the nearest centimetre. Note that when using the calculator, I did check that we were in radian mode. So the next thing is to determine the differential of h. Now you can use the CAS obviously to do this. But this is easy enough to do without the CAS. So we know that sine differentiates to cos, and using the chain rule, the differential of the inside is just going to be 1. So it is just going to be 4 cos, and remember the argument won't change, and then we'll have minus 2x, and remember here that pi is just a constant, so differentiating 3 pi x gives us just 3 pi, and of course the negative 4 here is just going to disappear. Part C, it says determine to the nearest centimetre the value of x at which the height of the building is maximum and state the maximum height. Well, it's just 2 marks. There's no reason that we have to use anything we've done before. We can go back to the graph. And I'm going to go analysis G-solve and max, and there it is. And we can see that x is 5.74 meters, and the y max, or the maximum height, is 20.57 meters. So now let's look at part D. An adventure company allows tourists to climb from the ground on the left of the building, then along the outside of the building to the top. The company installs a platform that allows climbers to rest on their way up to the top. The platform is located on the second half of the climb at the point where it is the steepest, and that means that we're looking at an oblique point of inflection. How high off the ground to the nearest centimetre is it positioned? So, remember this is 3 marks, so we can't just put down an answer we've found. Now we're talking about climbing this profile of the building along here. I think there's probably more than one inflection along there. So what I'm going to do is G-solve for inflection, and first one I found here is at 2.09 and 9.35. So we're going to look for points of inflection, and I'm going to state that I've got one at 2.09, 9.35, but that doesn't look like the steepest part of the climb. I'm sure there's another inflection, and indeed there is, and that one is at 4.19, 15.33. It seems to fit the bill. It's in the second half of the climb, and it's steep there. So let's put them both down and identify that we want this one. Remember, we're trying to make sure that we earn all 3 marks here. And therefore, we can say that the height of the platform is 15.33 meters.